Hello everyone, welcome back to my YouTube channel. I hope all of you are doing well. Today we will discuss about the lithium aluminum hydride. It is one of the reducing agent. In today's video we will discuss about the what is the lithium aluminum hydride, about its general introduction, and then how we can prepare the lithium aluminum hydride, and then what are the different properties of the lithium aluminum hydride, and then its application. So it is a reducing agent. Its formula is lithium aluminum hydride. Here the lithium carries the positive charge and there is a negative charge overall of this entity. Here the aluminium atom is the sp3 hybridized, and these four hydrogens are arranged in a tetrahedral manner. And the IUPAC name of this reducing agent is lithium tetrahydridoaluminate. And this molecule act as a reducing agent. Why it act as a reducing agent? Because it is a hydride generator. Means that we know that for any molecule to act as a reducing agent, it should give the H minus ion. So firstly, we will discuss about the general introduction of the lithium aluminum hydride. So the lithium aluminum hydride, it is a white color solid, and it act as a stronger reducing agent. Means that it is very much stronger than that of the sodium borohydride. Most of the reaction of the lithium aluminum hydride, they are carried out in the presence of the aprotic solvents like anhydrous ether. uh, we cannot use the water for the reaction of the lithium aluminum hydride, because from the water it takes the H plus ion, and the hydride from the lithium aluminum hydride combine to form the hydrogen gas. So therefore the reaction of the lithium aluminum hydrides are carried out in the aprotic solvent. Third one, it reduces the carbonyl group. Means that the lithium aluminum hydride, it is a reducing agent, and it can be used to reduce the aldehyde, ketones, acid, ester, amide, oximes, azides, anhydride. Means that it can reduce the polar multiple bond. So lithium aluminum hydride is generally used to reduce the polar multiple bond. It can reduce the nitrile, the nitro group, and the alkyl halide. So, the lithium aluminum hydride can reduce only the polar multiple bond. So, it does not reduce the isolated double bond or the triple bond, the double bond between the two nitrogen atom. But if this double bond or the triple bonded groups, they are in conjugation with the phenyl group, then the lithium aluminum hydride can reduce these groups. So from here we get the knowledge about that the lithium aluminum hydride can reduce the polar multiple bond, does not reduces the isolated double or the triple bond, but if these groups are present in conjugation with the phenyl group, then the lithium aluminum hydride can reduce these groups. Next we will discuss about the method of preparation. Means that how we can prepare the lithium aluminum hydride. So it can be prepared by a very simple reaction which includes the addition of the anhydrous aluminum chloride slowly to the paste of the lithium hydride under the anhydrous condition, that leads to the formation of the lithium aluminum hydride. It's a very simple reaction. You can prepare it in the laboratory by itself. Next, we will discuss about the what are the different properties of the lithium aluminum hydride. So the lithium aluminum hydride, it is a very strong versatile reducing agent. Why we call it is a versatile reducing agent? Because it can reduce the variety of the functional groups. It is found to be highly soluble in the diethyl ether and decompose at a temperature at 125 degree Celsius. So it is a very versatile reducing agent, and its reactions are carried out in the anhydrous ether, as it is highly soluble in the ether. Next we will discuss about what are the different applications of the lithium aluminum hydride. Here we will discuss about what are the different types of the functional group it can reduce and to which moiety they gets reduced. So here the lithium aluminum hydride can reduce the aldehyde group into the alcohol. Ketone group also reduced to the alcohol. It can also reduce the ester into the alcohol. Acids can also be reduced to the alcohol by the lithium aluminum hydride. The amides are reduced to the amine, and the azide group gets also reduced to the amine. But if the reaction was carried out in case of amide at the lower temperature, the amide gets converted into the aldehyde. It can also reduce the alkyl halide into the alkane. Yeah, we can say that if the alkyl group is attached to a living group, so in the presence of lithium aluminum hydride, this living group gets replaced by the hydrogen and we get an alkane. The lithium aluminum hydride can also be used to reduce the anhydride into the alcohol. It can also reduce the nitrile group into the amine. Acid chloride can also gets reduced with the help of lithium aluminum hydride into the alcohol. It can also reduce the nitro group to the amine. But if we have the aryl nitrite is there, so they get reduced into the diazo compound. Isocyanate can also be reduced to the amine in the presence of the lithium aluminum hydride. Lactone can also gets reduced with the help of lithium aluminum hydride, and they gets reduced to the diol. Okay, as we studied earlier that the isolated double or the triple bond can't be reduced by the lithium aluminum hydride. So therefore, like the benzene, alkene or the alkyne, they can't be reduced by the lithium aluminum hydride. Now we will discuss the general mechanism by which the lithium aluminum hydride can reduce a group. So the first step involves the nucleophilic attack by the hydride ion. So let us consider an example of a ketone. Here the lithium aluminum hydride is represented in this way. So here this hydrogen atom, because of there is a negative charge on the aluminum, it tries to get neutral. So this bond try to withdraw the electrons of this bond, so therefore this will attack on the carbon of the carbonyl group, because the carbon is positively charged here because the oxygen is highly electronegative in comparison to the carbon, so withdraw the electron density towards itself and generating a electrophilic center at the carbon. So therefore the attack take place at this position and we get this moiety. Here, this hydrogen comes from the aluminium hydride, so it is labeled as a red. The next step involves the protonation by the water. Yeah, we can say that the quenching of the reaction by providing the H plus ion to the reaction. So this H plus ion will be taken by the oxygen and we get the alcohol. So this is the general mechanism by which the lithium aluminum hydride can reduce a group. So if anyone asks about the order of reactivity, as we have said that it can be used to reduce the aldehyde, to reduce ketone, ester, amide and acid. So what is the order of reactivity of the lithium aluminum hydride towards these groups? So here the order of reactivity follow this order. If we have a molecule in which both we have the aldehyde or the ketone groups are present and we have given only the one equivalent of the lithium aluminum hydride, so which group will reduce first? So this is the order. First of all the aldehyde gets reduced, then we have ketone, after that we have ester, then we have amide and we have acid. As we have said earlier that the reaction of the lithium aluminum hydride are carried out generally in the aprotic solvent, because it takes the H plus ion from the water and leads to the formation of hydrogen gas. So in case of acid also, as the acids, they can give the H plus ion. So this H plus ion can react with the hydride ion from the lithium aluminium hydride, and it leads to the formation of the hydrogen gas. So the best method for the reaction of the acid with the lithium aluminium hydride, we have to first convert the acid into the ester and then carry out its reduction with the lithium aluminium hydride.